In today's video, we're going to discuss literal equations. We're going to talk about what they are and how to solve them. First off, what is a literal equation? A literal equation is an equation that involves more than one variable. You can see in this example below, in this equation, and I can tell it's an equation because it has an equal sign, I have not just one variable, I have three. I have x, y, and z. Right now, this equation is solved for z because z is the one and only variable that is solved, that is by itself. I can rearrange this equation and solve for any of the other variables, and that's what we're going to be doing today. How do you solve them? Well, we solve them like any other equation. First, we locate the variable in the equation that we are trying to isolate. Okay, we draw, this isn't included in our steps, okay, but we also draw a line of balance. And what we do to one side of the equation, we're going to do to the other. In order to get our variable by itself, we are going to isolate the variable by using inverse operations, just the same way as we did any equation. To undo addition, we're going to use subtraction, and in reverse, we can do the same. Or to undo multiplication, we can use division and vice versa. Let's look at our first few examples. So these first examples, I'm going to undo using addition or subtraction. And you can see that I'm going to do that because I have a bunch of pluses and minus signs. So let's look at example number 1. So we want to solve for a. Step number 1 is to identify or find the letter that you want to solve for. I would recommend writing this down. Make sure you write down this problem and circle and do with me what I demonstrate. So I'm going to find a in my equation. There it is. I put a box around it. I'm saying to myself, that's what I want by itself. I'm going to draw my line of balance. And I'm going to say, hey, this right here is going to be the side that I want to keep my variable on. So if this is where I want to keep my a, what do I want to get rid of? I want to get rid of the b. Remember how to get rid of things? We use inverse operations. So I look in between the a and the b and I see that it says a plus b. So how do we undo addition? We undo addition with subtraction. So underneath the b, I'm going to write minus b. Now on the other side, are there any b terms? No, there's not. So instead of writing it underneath, I'm going to choose to write it to the side, minus b. I'm going to simplify. A is left over. The z plus b and minus b cancel out, those zero out. And I am left with 14 minus b. And these are, if I separate them, they're not like terms. I cannot simplify it any more than that. And believe it or not, that is my final answer. I'm going to rewrite it down here so you can see more easily. Now you might see someone write the answer as the following. And you might say to yourself, is that right? Well, check it out for yourself. Is the 14 positive in both equations? Yep, it is. Is the b negative in both equations? Yes, it is. So these two equations are equivalent and you can choose to write them either way. You can choose to write them either way. All right, let's go ahead and try this next one. So let's try example number 2. Solve for y. I'm going to identify where my y is. I'm going to put a box around it. I'm going to draw my line of balance. And I'm going to ask myself, what do I want to get rid of? Well, this side of the equation says y minus 18. So how do you undo that operation? So I undo subtraction with addition. So on the left-hand side, underneath the minus 18, I'm going to write plus 18 because that's going to undo itself. And on the right-hand side, well, if I wrote 18 here, are they going to be able to combine? No, 18 doesn't have a variable with it. So I'd actually just recommend writing it over here to the side. So b plus 18. Simplify. Okay, y is left over. minus z and minus 18 and plus 18 zero out. And that's leaving me with b plus 18. This would be my final answer. I started with 2 variables, I end with 2 variables. All right, last example on this page. Now there's 3 variables on this one. R, P, and S. This says to solve for R. So I'm going to identify my variable, find it. There it is. Draw my line of balance. I notice that P is not on the same side of R, so I can leave it alone. But S and minus 3 are on the same side. So I need to get rid of these. Now you might say, well, which one do I get rid of first? It doesn't actually matter. I'm going to just use my rule of thumb. I always get rid of whatever's furthest away to begin with and go from there. So furthest away is minus 3. So it says R plus S minus 3. Well, how do I undo the subtraction? How do I get rid of minus 3? I'm going to add 3. Now I'm going to make sure I write plus 3 on the other side of this line. So not underneath S and not underneath R, but underneath P. I might say to myself, let's add plus 3. Now these are not like terms. So I'm going to write P plus 3. Or you can write 3 plus P. But P plus 3 is equal to what's left over, R plus S. I'm still going to put a box around R, that's still there. Negative 3 and plus 3, 0 out. Now, have I reached my goal? Is the box that's around R, is that all I have on that right-hand side? And the answer is no, I still have this S that I need to eliminate. This side of the equation says R plus S, so how do I undo addition? I'm going to use subtraction. I'm going to rewrite this over here so I have more room. P plus 3 equals R plus S. I'm going to undo plus S by minusing S. And I'm going to minus S over here. On the left-hand side, I have P plus 3 minus S equals, on the right-hand side, I have R, and the S plus S and minus S, 0 out. So this next one is a try on your own. I'm going to get you started. Circle your variable that I'm solving for. It says solve for A. Draw your line, and now ask yourself what you need to get rid of and how those operations are occurring. Do I have addition going on or subtraction going on? Pause the video, and when you're ready to check your answer, press play. All right, let's check your answer. I need to get rid of minus b and minus 9. I'm going to work furthest away first. So I'm going to get rid of minus 9 by adding 9. So I have p, and p and 9 don't combine, so p plus 9, I'm going to keep that in between my two terms, equals a minus b. Still solving for a. How do you get rid of minus b? Well, I add b. And I'm going to add b. Now, it doesn't matter where I put the plus b. I could have written it here instead. But no matter what, it does not simplify. So I have p plus b plus 9 equals a. Now, you might say, oh, I would have put it underneath the 9 plus b, and these two would have been switched. That's fine. Remember, I can have my terms. I can have these things right here in any order, as long as they have the correct positive or negative in front of them. All right, let's work with multiplication and division. So the last few problems were only addition and subtraction. Let's talk about multiplication and division. How do we undo multiplication? We divide. And how do we undo division? We multiply. On this fourth problem right here, I'm solving for W, so I circle W. Now, what does this mean? A equals 7W. I want you to make sure you realize that that means A equals 7 times W. Mathematicians are kind of lazy and they leave that multiplication sign out. It's a common notation to leave it out. And you got to know that. So if it really means 7 times w, how do you undo that multiplication that's going on? Well, we just identified to undo multiplication, we have to divide. So instead of using this old-fashioned division symbol, we're going to graduate to the fraction bar, the line, to use division. And underneath the times by 7, I'm going to write a divide by 7. I'm going to draw my bar, and if I do it on one side, I have to do it on the other. So underneath A, I'm going to put the fraction bar and divide by 7. What does that leave me with? Well, on the left-hand side, I am simply going to copy and paste it below. That can't be simplified, so I don't need to do anything other than copying and pasting. On the right-hand side, timesing by 7 and dividing by 7, they undo each other, and I only have w left over. There's nothing in the denominator, so I don't need to keep a fraction bar. And that would be my final answer. All right, let's look at problem number 5, solving for y. Where is my variable? There's the y. That's what I want to get by itself. There's my line. Okay, what is on the same side as y that I need to get rid of? 4. I need to get rid of 4. Well, what does this mean right here? This means y divided by 4. So how do I undo that division? I multiply by 4. When I times by 4 and divide by 4, those undo each other. And I'm left with, on the right side, y equals, now what did I just forget to do? Hopefully you caught my mistake. I times by 4 on one side, but I haven't times by 4 on the other side, so I need to make sure I go ahead and do that. So x times 4. Now remember, we like to simplify our answers and put our numbers first and variables second, and we can drop out that multiplication sign. All right, your turn. I want you to try both of these examples. Decide if you need to use multiplication or division to solve them. Pause the video when you're ready to check your answers. Press play. Solve for w. Here's w. Draw in my line. This says w divided by 2. So how do I undo that? I'm going to times by 2 on both sides. The 2's cancel, and I'm left with w equals g times 2. But we're going to simplify our answer to correct mathematical notation to 2g. On this next problem, drawing our line, we want to solve for x. We know that this means 3 times by x. So to solve, I'm going to divide. And on the left-hand side, the 3's cancel out, not zero out. And I'm left with x equals y divided by 3. Remember, I copy and paste it. And that's my final answer. All right, one last type of problem. You'll notice on this problem it says to solve for x, and here's my x right here in the middle. Now, what operations are going on? I have 32 times x times y equals w. I have 2 multiplications, so how do I need to undo that? I need to undo with division. Here's the nice thing about multiplication problems. If these are all multiplied together, whatever I need to get rid of, I can divide at the same time. So I'm going to make one big division bar underneath everything. If x is what I want to solve for, I need to, since it's timesing by 32, I need to divide by 32. Sweet. I'm dividing by 32 by putting it in the bottom of that fraction. And I also need to divide by y. So underneath, I'm going to put y in the bottom of that fraction. It means I'm dividing by y. Remember, if I do it to one side, I have to do it in the other. So I divided by 32, and I divided by y. Let's simplify. Timesing by 32 and dividing by 32 cancels. Timesing by y, dividing by y cancels, and I'm left with only x left over equals, copy and paste this thing, w divided by 32y. And that right there is my final answer. This last one is a try on your own. Pause the video, and when you're ready, go ahead and press play. Okay, let's go ahead and practice. Drawing my line, here is g. This simply means 2 times g times h, so I'm going to undo this all with division. Since I'm timesing by 2, I'm going to divide by 2, and since I'm timesing by h, I'm going to divide by h. Those cancel, and on the left-hand side, I'm going to do the same. Divided by 2, and divided by h. I'm going to copy and paste this below. G is the only thing left over here, and I have my final answer. Your assignment is on Alex. If you have any questions, please reach out. I know sometimes this topic can get a little tricky, so please don't hesitate to send me an email through Canvas if you need any help. Thanks.